everyone, so this video is about C strings. A C string, or strings in general, are used to store character data. That's what they're for. And typically they're used to store character data involving many characters. So for example, if you wanted to store the word hello into a variable, you would use a string to do this, okay? If you want to store a sentence, you would use strings to do this. Uh, in C though, this is a very C thing. We typically would use strings to store things like words and sentences, but not necessarily a bunch of character data. So for example, if I was going to store the answers to a multiple choice test, like all of the answer set, those are just characters, right? I wouldn't use a C string to do it because they're not really related characters. Like the fact that the first answer was A and the second answer was C, it doesn't actually mean that there's a meaning to AC, right? So we wouldn't use something like a string to store uh, character data that aren't actually things that are sort of like the sequence and the orders of the letters have sort of meaning besides the fact that it was the first question's answer and the second question's answer and so on. So we want to be careful about what we store into a C string and what we don't. Okay, because C strings aren't exactly character arrays, even though that's how they're defined. And we're going to talk a lot about that, when we look at the example. And this is a really important concept because C strings have do something that is different from strings in other languages. Okay, and that is they're null terminated. So we're going to talk about what this means in detail in a moment, but I just want to bring this to your attention. So let's get started with a simple example. Okay, so here's a program. And this program is not an exciting program. It's a program that basically says, oh, okay, I have a string here, and I'm going to put hi there into the string. Okay, so I want to walk through what this actually does because this seems really simple. So obviously, this program is going to have a variable. It's going to have hi there in the variable, and then I'm going to print it. The format code to printing a string is %s for string. And let's take a look at what this code will do, okay? Now, if I were to walk through this code and I was to draw what's going on in memory, um, the this declaration, so ignore everything after the equal sign. Just look at this part of the declaration. This says create an array that has 12 elements in it. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I hope I got the right one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I got too many. So this array is actually too big. There we go. This is a 12 element array. It's indexed from 0 to 11, but there are 12 elements in this array. Okay, so if I were to count the boxes, there are 12 boxes. Okay, but indexed from 0 to 11. So here's my array. That's just what this part says. This part does not make it a C string. This is just an array of 12 characters. The thing that makes it a C string is what I put on this side, which is double quote hi there. Now, this does what you think it does, at least partially. So if I have this initialization, what it's going to do is it's going to put hi there with an exclamation mark into the array. That part is exactly what you expect. What it doesn't tell you is that if you use these double quotes like this, then it's not just the characters hi there, it's hi there followed by a character called the null character, which I'm going to draw as /0. So this is called the null character. Okay, it's a null character. It is ASCII code 0, so ASCII 0. Okay, so that's the value of this character. It's valued at 0. Okay, so ASCII 0, also called the null character, is put into your array after the exclamation mark. So you see how there's like hi there, and you don't actually put a null character explicitly into this character string. But what it will do is after hi there, it will put this null character into the string for you, into the character array for you. And this is really, really, really important, okay? Because it is the source of many errors. We're going to talk about that in a moment. But for now, let's just run this program. So let's clear out this. Oops, clear. So GCC C string.c. And if I run this program, it says hi there. Not very exciting program, but that's what it will do. Now, remember that this null terminating this character, null character, terminates our string. So this is really important. The null character tells you where the end is. So what this means, let's say that I took my program here and I did the following. My string square bracket 2 is equal to single quote, okay, single quote because that's one character. Not, notice it's not double quote here, single quote. Single quote null character. So this is the null character right here. Let's see what this will do to our code. So what this says is I'm going to put this character, a null character, into the array at position 0. So what this is going to do is do this. Now, if I do that, what this means is the following. My string is null terminated. So the moment I hit the null character, my string is over. So even though I never touched there, I never touched any of these characters, by putting a null character into this position, my string, if I were to print it again, would only say hi. So let's try this out. Okay. And the first one is still hi there, but after I put in the character null, notice my string turns into hi because I ended it after the word hi. Now, if I want to bring back there, by the way, if I want to bring back the other part, all I have to do is say my string square bracket 2 is equal to, now I can put anything I want here. Obviously, it will have an effect on the output, but anything that isn't a null character, like a space, that will put the there back. I don't even have to put anything else. I just have to make sure that it's not the null character there. So GCC right here, and if I run it again, oops, sorry, I didn't print it out after I did that. Let me do that. So if I did this again, sorry, let's compile this again, GCC, and you can see just by putting a space back, like overwriting that null character with a space, I erase the null character, and therefore my string doesn't end there. It ends when it sees a null character, which, oops, which happens to be at the very end, right there, right? Like that's where it ends. So this is a really, really important concept, okay? And by the way, it doesn't have to be a space. I could have done a space, but I could have also, any character, okay? Like if I put an underscore, for example, it would also bring back the there. Obviously, it's going to print an underscore now instead of just a space, but it basically means that we have to be very careful about our null characters, okay? So this idea of null character at the end, this is what makes a C string also known as a null terminated character string. So you might see this, like C strings are null terminated character strings. And this, by the way, is one of the biggest, most expensive design decisions, design errors ever created. This decision to create C strings so that you use this null character to say this is the end. This was a really expensive decision, like money expensive. Why is this expensive? So let's think about what we're trying to do. We're trying to say we have a bunch of characters and they represent like some sentence, some word, something like that. And remember what I told you when we started learning about arrays, that whenever we write an array, we need to track a few different values. Now, two of those values are pretty important to us. They are the capacity and also the number of elements used. So remember I said to talk about capacity and used. Capacity is how big the array is. So in this case, this capacity of this array is 12 because I created an array that has 12 elements in it. That's the capacity. Now, I'm using it to store high there. Now, if I count the characters, 1, 2, 3, 4, 5, 6, 7, 8, and then an exclamation mark, that makes it 9. So in this case, my capacity is 12, my use is 9. Okay, I'm using 9 of the characters, right? Now, I have to record the fact that I'm using 9. So when the designers of C were trying to decide on how they're going to create these C strings, they thought about it. They said, well, you know what? We would have to know where this thing ends. And we can do that in one of two ways. We can say, well, how many characters is in this array that is part of the string? We can store that number. Or now, if you do that, what's the cost of storing a number? You go, well, 9. We can store that in, say, an integer. An integer is 4 bytes. Modern C is 4 bytes. Back when they were doing it, an integer would have been smaller than that. But it would have taken them more bytes to do it. If they only use 1 byte, like one character's size, worth of data, they could only store up to 256 because 2 to the power of 8 is 256. So they can't store, if they decided to design a C string by saying that you can say how many are used, but with only 1 byte of data, your strings would be restricted to a size of only 256 characters. Now, if you use 2 bytes, you can get that's 16 bits, you can get 64,000 characters. So any string that's 64,000 characters long is fine. Longer than that is not. 2 billion if you use 32 bits, right? So the problem is that it would need more storage to actually decide, like to actually store this number, because we don't want our strings to be restricted to only 256 characters long. So the designers decided to, well, if we just slap a null character at the end, then we would know when it ended. We just have to look for this null character. Then we don't have to store this used value. So every time we see a null, we know it's at the end. And this is basically a trade-off that they did. By putting a null character at the end, they're not restricted, first of all, by how big the string could be. The string could be very, very long. That's not a problem. Um, they're not restricted by, like, they don't have to use as much space to store this information about how many was used, because remember, for any string that is significant in size, that's more than 256, we would actually have to use more than 1 byte. And when you create these things, they're sort of fixed. So they were able to save memory, save the amount of memory they would need to store the same information by using this null character. Okay, so they traded some uh, some things off by they were able to use less memory, but they traded off a few things. They traded off uh, quickly knowing how long the array is, how long the string is, for example. They traded that off. They traded off security, which they probably did not realize at the time. So many of the big security holes from C has to do with somebody overwriting this character. By overwriting this character, you bleed into the next, and that's where there's a lot of security flaws that were created because of this design flaw in the C language. So it is very important when we're writing code using C strings that we actually are very aware of this null terminating character. Like that's what mostly I'm talking about, the null terminating character, the fact that it exists. It's a very important idea. And if you accidentally overwrite it, you don't know when the string is going to end. So if I were to erase this null character, it is possible that this next byte is also null without me saying anything. But it is also possible that this next byte contains complete garbage, AB. And when will this end? Well, whenever there is another null. And I don't know where that is. And now once I get past the end of this array, I don't know what variable is going to be here. I don't know what's actually in this memory location. And it is possible that I might end up writing into a memory variable that belongs to some other variable. It is possible that I will be reading data from another variable. So if you ever have a bug where you have a string and the string should say ABC and you see ABC and then garbage, utter garbage afterwards, what you've done is you've accidentally gotten rid of a null character that you shouldn't have gotten rid of. Okay? So, in any case, that is my intro to C. I'm not trying to scare you, but be very careful about that null character. And that's it for now. Thanks, everyone.